Hello, today we're going to be looking at Unit 7, Day 1. We're going to look at angles in polygons. Remember, a polygon is a closed plane figure with 3 or more segments. So when we say a closed figure, that means there's no gaps in the edges. They're all the way closed. Okay? And then a plane figure, that means it's going to be flat. It's not three-dimensional. Okay? And then the other thing we have to remember is that it's made with segments. That means there's not going to be any curves to it because segments are parts of lines. Okay? So the next two things we need to talk about are two different kinds of polygons we can have. We can have a convex polygon where all the vertices point outward. So for example, if I were to draw like a little house type of thing, pretend that's straight, okay? Then I notice when I look at this, if I point the direction that all of my vertexes are going, my vertices, they're all pointing outward, okay? That is a convex polygon. A concave polygon is where one or more vertex points inwards. So in this case, I might have something like this. And when I have something like this, then, so here I can see on this one, I have this vertex points, oops, I wanted green. This vertex points out, this one points out, this one points out, this one points out. But this vertex here is pointing back inside my figure. So I like to think of it as being caved in, and that's how I remember that it's concave, not convex. Okay, so take a moment and look at these 4 images that we see right underneath here and determine if yes, we're a polygon, or no, we're not. If we're yes, are we convex or are we concave? If not, why not? Okay, so if you want to pause the video and do that, you are more than welcome to. All right, so let's look at this first one. On my first one here, I can see that it is, yes, a polygon. All of my sides are made with segments, and they all close. They touch each other everywhere. And all of my corners point outwards, so this is yes, and it is convex. Okay? When I look at the next one, hopefully you noticed that it has curves here and here, and so we can't have any curves, so we have to say no, this is not a polygon. And why not? Because there are curves. On this one, all of my sides are straight, it's flat, and I don't have any gaps in my sides, and there's no curves. So I can say yes, this is a polygon because I have these 4 corners that point inwards, push inwards, are caved in. We know this is concave. And my last one, we have to say no to this one. Yes, I have straight segments, but I have an opening right here. It's open. These 2 corners don't make a corner. They don't touch each other. So we have to say no, this one's not a polygon because it is not closed. Okay, next we're going to review classifying polygons. You did most of this when you were in middle school math, but we are going to add on just a little bit. So these are just most of these review. Triangle has 3 sides, quadrilateral has 4 sides, pentagon 5, hexagon 6. We tend to forget the poor heptagon. Heptagon is 7, octagon is 8. We tend to forget nonagon is 9, and decagon, like a decade, is 10. And then this might be new to you. 12 sides is dodecagon. The prefix do, like dozen, meaning 12. So dodecagon. Do is like 2 more than 10. So dodecagon is 12. Notice we skipped 11. And you can have polygons that have 13 sides, 14 sides, 15 sides, an infinite number of sides. So these are the only ones that you have to know from heart. but anything after that, we're just going to call them n-gon, where n is the number of sides. So let's say you have an 11-sided figure, we'd call it an 11-gon. If you had a 32-sided figure, you'd call it a 32-gon. Okay, so that's what we would do for anything that is not a 3 through 12 or 11, okay, sided figure. We'll just call them an n-gon, where n is the number of sides in the figure. They do have names, and you can Google them. Some of them are fun, but they tend to get long and tedious to say. The next thing we're going to look at is the polygon interior angle sum. That is the sum of the interior angles in a convex polygon. So all my corners are pointing outwards. Can be found using this formula right here. The sum is equal to n minus 2 times 180, where n is the number of sides in the polygon. So if I have 3 sides like a triangle, I'm going to put a 3 in for n, and I'll do 3 minus 2, which is 1, and 1 times 180, there's 180 degrees in a triangle. If I have a quadrilateral, so I have 4 sides, then I put a 4 in for n. 4 minus 2 is 2, so I have 2 times 180, that's 360 degrees for that shape. Okay, so this formula is very useful for finding the sum of all those angles that are on the inside in a convex polygon. Okay, oops, I went too far. Okay, so let's look and see how we apply this. My example first, it says, what is the sum of the internal angles in a hexagon? So we need to remember that a hexagon has 6 sides, so n is going to equal 6. So in my formula, I'm going to do 6 minus 2 times 180. That's going to give me my sum. So I'm going to grab my calculator. And you can put this all in your calculator at one time. I'm going to open a calculator page. You can do parentheses 6 minus 2, or you can do that part in your head and do 4 times 180. And I get an answer of 720. So every convex hexagon in the whole world has an angle sum of 720 degrees if you add all 6 of its angles together. Okay? All right, the next one is asking me the same thing, but it wants a 14-gon. So this time, we're going to know that n equals, oops, I wanted to change colors here. N is going to be 14 sides this time. So I'm going to do 14 minus 2 times 180 to get my sum. Okay, so when I solve this one, I'm going to grab my calculator, and I'm going to do 14 minus 2, oops, I forgot my parentheses, 14 minus 2, or you can just do 12 in your head, times 180, and that's going to give me 2160. So 2,160 degrees is what all 14 of those angles in my 14-gon would add up to. All right, let's look at these 2 examples, how we apply, like why do we need to know this information, when is it useful? So let's look at these 2 problems here. Number 1 says to find the value of A. A is this angle right here. I want to know how big it is. So if I look at this figure and I can see we have 1, 2, 3, 4, 5, 6 sides, so this is a hexagon. And we just looked up here, we know that a hexagon has a sum of 720 degrees. So if I take all of these angles here that I have and add them together, whatever is left out of 720 will be how big A has to be. So I can add together my 88 plus my 142 plus my 105 plus my 136 plus my other 136. So I'm adding together the 1, 2, 3, 4, 5 angles that I do know. Let's see what that sum is. 88 plus 142 plus 105 plus 136 plus 136. That's going to give me 607 degrees that I've already used for all 5 of these angles, and then I have this 6th angle left. And I know together all 7 of them or 6 of them are supposed to add to 720 degrees. So I'm going to see what's left for that angle by subtracting the 607. So 720 minus the 607 leaves me with 113 degrees. So the value of A is 113 degrees. Oops, I almost made it a percent. Degrees. And again, that A is not the name of the angle. That's a variable in the corner representing 113 degrees. Whereas this A over here is the name of this angle. Okay? All right, let's look at this one, number 2. And let's see how many sides we have. I'm going to start at A. 1, 2, 3, 4, 5. So this is a pentagon, which means we have 5 sides. So my value for n is 5. So when I do 5n minus 2 times 180, that's going to give me my sum of all 5 of these angles. So I'm going to grab my calculator, and I'm going to do 5 minus 2, close parentheses, times 180, and again you could just do 3 times 180. 540 degrees is my sum. That is not the answer to this problem. This problem wants me to find each angle. So I know if I add all 5 of these angles together, I'm going to have a sum of 540 degrees. So when I add A, oops, I wanted to switch colors. A is 4x plus 10 plus B. B is 6x plus 10 plus C, 5x minus 5, plus D, 4x plus 5, plus E, 7x. Those 5 angles, 3, 4, and 5, will all add up to 540 degrees. So now this is all the geometry in this problem. Everything else in this problem is going to be algebra 1. I'm going to just combine my like terms and solve for x. So when I look at all my x's, I have 10, 15, 19, 26, 26x, and then I have 10, 20, 15, 20, plus 20. Let's check my math and just make sure I have that correct. 4 plus 6 plus 5 plus 4 plus 7 is 26 x's, and 10 plus 10 minus 5 plus 5 equals 20. Okay, we're good, and that equals 540. So then I'm going to subtraction property of equality. (26x) equals 540 minus 20 is 520. Division property of equality. Oops. And I get x equals, let me put this in the calculator, 520 divided by 26 gives me 20. That's still not our answer. It says to find each angle. So I have to come over here and I have to put a 20 everywhere I see an x so that I can find each angle. So the measure of angle A is going to be 4 times 20 plus 10. So 4 times 20 is 80 plus 10, that is 90. It's a right angle. It even looks like a right angle. That's not always the case. Okay, the measure of angle B, let me give myself a little more room here. The measure of angle B equals 6 times 20 is 120 plus 10, 130. The measure of angle C, 5 times 20 is 100. 100 minus 5 is 95 degrees. The measure of angle D is 4 times 5 is 80. 80 plus 5 is 85 degrees. And the measure of angle E is 7 times 20, which is 140. We can check this if all of these angles, all 5 of these angles we know should have a sum of 540. So if I do 90 plus 130 plus 95 plus 85 plus 140, I'm going to get a value of 540 degrees. So that does work. These are my correct answers. Okay? All right, let's look at the third example. The third and fourth examples are interesting because you're kind of going to have to work backwards on these examples. The sum of the measures of the interior angles of a convex polygon is this. How many sides does the polygon have? So the sum equals 2340. I have a formula for the sum. To find the sum, I do n minus 2 times 180. That gives me 2340. I'm trying to figure out what is n. How many sides does this have? What is the number of sides, right? That's what n is the number of sides. So I have this n minus 2 being multiplied to the 180. So the first thing I have to do is get rid of this multiplying by 180 by dividing it out. When I do that, that's going to leave me with just the n minus 2, and since it's all by itself and not being multiplied anymore, I don't need those parentheses. So I need to figure out what is 2340 divided by 180. That's 13. So now I have n minus 2 equals 13. I'm going to add 2 on both sides. Addition, property of equality. And the number of sides in this figure is 13 plus 2, 15. Okay, let's do another example just like that. Okay, on the next one, how many sides does the convex polygon have if the sum of the interior angles is 360? So my sum equals, or not 360, 3960. 3,960 degrees. I know the sum can be found using the number of sides minus 2 times 180. That's going to give me 3,960. First thing I'm going to do is I have n minus 2 times 180. So I'm going to untimes the 180 by dividing it out. When I do that, let me grab my calculator. 3960 divided by 180 gives me 22. So n minus 2, we don't need the parentheses anymore, equals 22. Okay, that is not my answer because I still have n minus 2. I want to know what n is. So I'm going to add 2 to both sides. And my value for n is going to be 24. This figure has 24 sides for this convex polygon. Okay, so notice in both cases, I divided by 180 first, and then I still had to add 2. Don't forget the add 2 part. That's easy to forget. All right, let's do a little bit of a review. Remember, we talked about in the last unit regular polygons. It's a polygon where all my sides are congruent. So if all of these are regular polygons, all 3 of those sides are the same, all 4 of these sides are the same, all 5 of these sides are the same, and all 6 of these sides are the same. And then remember, all your angles are going to be congruent. So these 3 angles are all congruent. These angles are all congruent. These angles are all congruent. And all 6 of these angles are congruent. So if I'm looking at these regular polygons, we already know that when I do a triangle, if I do 3 sides minus 2 times 180, I'm going to get 1 times 180. And so that's 180 degrees for my internal sum of those 3 angles. We've done that a lot this year, right? And I know each angle in my regular polygon, if I take that 180 and I divide it by 3, each angle here is going to be 60 degrees. We've done that before, okay? If I look at this one, I have 4 sides, so I would do 4 minus 2 times 180, which is going to give me 2 times 180, 360. So the 4 angles in my quadrilateral are going to add up to 360 degrees. And when I take that 360 and I divide it into 4 equal angles, we should hopefully already know that those are all going to be 90 degrees. We're actually going to end up with a square here where all those angles will be 90 degrees. Okay, and then back over here on this one, we've already done a pentagon already today as well. 5 minus 2 times 180 was 3 times 180, and we got 540 degrees. So if I want to find each angle, if I do that 540 and I divide that into 5 equal angles, 540 divided into 5 equal angles is going to give me 108 degrees for each one of these angles in here. They're all going to be 108 degrees. Okay, and then my hexagon, last but not least over here, my hexagon. I have 6 sides minus 2 times 180. We've already done this one today, a hexagon. We did twice today already, 720 degrees. And so then if I want to find out what each of these angles is, I can take that total and divide it into 6 equal angles. So 720 divided into 6 equal angles is 120 degrees. So each angle in here would be 120 degrees. Okay, and you can do that. You can keep going. We only went up to a hexagon, but you could do a heptagon, an octagon, a nonagon, all the way up for forever. Okay, let's look at example 5. It says find the perimeter of a regular hexagon. That's important. Hexagon ABCDEF. If BC equals 3x plus 6 and EF equals 4x minus 2. Let's draw a picture. So I want a hexagon. The way I draw hexagons, I'm going to make that a little bit thinner. The way I find is the easiest way to draw hexagons, and it doesn't necessarily mean that they're going to look regular, but I do a horizontal and then like a big less than and then a big greater than, and then I just connect. And it's A, B, C, D, E, F. When you label a polygon, this is important. When you label a polygon that you're drawing yourself, you have to pick a corner and then walk around it along the edges. You can't zigzag around your figure. So if I put A here, I only have two options for B. I can either go up along this side or I can go down here. I can't come and put B across my figure or over here. I can't skip corners. So generally, we'll go clockwise, but that's not always the case. Okay, and then it tells me that BC is 3x plus 6, and EF is 4x minus 2. Now, if this is regular, I know all of my sides are equal to each other. So my 3x plus 6 is going to be equal to my 4x minus 2. To solve this, I'm going to keep my x's positive. I like to move my x's first, so I'm going to subtract that 3x over. Leaving me with 6 equals 1x minus 2. Then I'm going to do my addition property of equality and add 2 to both sides. And that's going to give me that 8 is my value of x. Now, it didn't tell me to find x. It told me to find the perimeter. So I need to add all my sides together, which means I need to know how big a side is. So remember, my sides are 3x plus 6 and 4x minus 2. So if I come over here and I say, okay, this is 3 times x plus 6, and this is 4 times x minus 2, where we just found x to be 8. I know this side is 24 plus 6, so it's 30. This side is 4 times 8 minus 2, so it's also 30, which it should be, right? Because we just said these two sides are equal to each other. All my sides are 30 units long. So to find my perimeter, I have 6 sides, so my perimeter is going to be 6 times 30. My perimeter of this shape is going to be 180. I don't know what my units are. I'm just going to say units. Okay? Let's look at this next situation. What is the measure of each interior angle in a regular pentagon and a regular decagon? So we've already done it about 3 times. A regular pentagon, we know the sum when we put an n value of 5. We know we're going to get a sum of 540. Okay? So if I want to know the measure of each interior angle in a regular pentagon, I can take that 540 and divide it into 5 equal angles and get 540 divided by 5. We already did that right up here, right? We did 108 degrees. So we've already actually answered this question in these notes. So when I have a pentagon, all those angles will be 108 degrees. If I have a decagon, decade, 10 years, my value for n is going to be 10. So I'm going to do my sum is going to be 10 minus 2 times 180. Let's see what our sum is going to be. Grab my calculator. Parentheses 10 minus 2, or you can just do 8. Oops, I typed in 8. 10 minus 2, or you can just do 8 times 180 is going to give me 1,440. Okay, so that's the sum. That's what all the angles add up to in my decagon. Okay, if I have a regular decagon, that means all 10 angles will be equal. So if they have to all add up to 1440, and there's 10 of them, then each one will be 144 degrees. The more sides you get in a regular polygon, the more obtuse your angles will become. They have to open up further to fit more sides in. Okay? So you have to use this formula, n minus 2 times 180, for each shape to find its interior angle sum. But now we're going to talk about exterior angles. Just as a little quick reminder, an exterior angle, when you have a polygon, your exterior angle occurs when you extend a side, right? And so then when you extend that side, the side next to it and the side you just drew, that makes your exterior angle. Okay? And when you look at just one exterior angle at each vertex, the sum will always be 360. It doesn't matter if you're working with a triangle, if you're working with a quadrilateral, if you're working with a decagon, a 48gon, the exterior angles will always add up to 360. Okay, so if I take this figure that I just drew and I have this exterior angle here, and then I take over here and I've got another one here, they may not be the same size, and then I extend this one. Again, they could all three be different if my figure's not regular, or if it's scaling, all three will be different, but they will all add up to 360. If I have a quadrilateral, they'll all add up to 360. A pentagon, my exterior angles will always add up to 360. Okay? And when you have a regular polygon, they'll always be exactly the same. So if I look at a heptagon, and that's a 7-sided figure, I know all 7 of those angles are going to add up to 360. So to find out what each one is in a regular polygon, I'm going to divide this by 7. So if I come back to get my calculator and I do 360 divided by 7, I get a fraction. So I'm going to go menu, I'm going to choose number 2 for number, and I'm going to take that and convert it to a decimal. When I hit enter, I get 51.4286. I'm going to say 51.429. It's an angle. We could probably just say 51. 51.429 degrees for the exterior angle. Okay, my hexagon, again, it doesn't matter how many sides, they're always 360. I know I'm going to divide it by 6 angles, 6 exterior angles. So that's going to become 60 degrees. Okay, so if I look back at that table that we did right up here, and I were to add on exterior angles, right? So if I were to come out here like this and look at my exterior angle out here, I have 3 angles here. So if I do for my exterior, I have 3 exterior angles. If I take 360 and divide by 3, I'm going to get 360 divided by 3 is going to be 120 degrees. So if this one's 120 and this one was 60, notice, remember, your exterior angle and the interior angle next to it should be supplementary because they make a line all the way across. We extended this line. Okay? On the next one, if I look at the exterior angle down here, I'm going to do exterior angles all across here. So this exterior angle, if I have 4 of them, when I take that 360 divided into 4, that's still going to be 90. When I extend a side, I'm going to have 90 on both sides. 90, 90, 180 for that whole piece. Here, exterior angle, I have a pentagon, so now I have 5 sides. Oops, not 180, 360. Always 360 for your exterior angle. Divided by 5 is going to give me 360 divided by 5 is going to be, let me grab a calculator, oops, 360 divided by 5 is 72 degrees. Which should make sense because if I have 108 degrees there, when I extend it, I'm going to have 72 degrees here, and together they make that linear pair, 180 degrees. And then this last one, we just did the exterior angle for a hexagon, and we said that when I took 360 and divided it by 6, I got 60 degrees, which again makes sense. If I have 120 here, I'm going to have 60 there. So as your side numbers gets bigger, as the number of sides you have gets bigger, your interior angles are going to get smaller, your exterior or bigger, and your exterior angles are going to get smaller. Okay, how can we apply this information? Let's look at number 8. Number 8 says to find each exterior angle. So I don't care how many sides I have. I can count them. 1, 2, 3, 4. I've got 4 sides, but I don't care. The exterior angle sum is always 360. So if I take all of my exterior angles, one exterior angle from each corner, they're going to add up to 360. Okay, so I'm going to have I'm going to start here, 3 times z minus 2 degrees plus 2z plus 4z plus z plus 96. That's going to add up to, no matter how many of them I have, it's always going to be 360 when you're working with exterior angles. First thing I'm going to do is I'm going to distribute right here. When I do my distribution, I'm going to have 3z minus 6 plus 2z plus 4z plus z plus 96 is equal to the exterior angle for everything is always 360. Combine my like terms, 3z plus 2z plus 4z plus z. So that's 5, 9, 10 z's. Then I'm going to have a minus 6 and a plus 96. So that's going to be plus 90 equals 360. Subtraction property of equality. $10z is going to equal 270. Divide both sides by 10, and the value of z equals 27. Now, that is not what it asked me to find. It asked me to find each angle. So I have to come in here into each of these z's, and I have to substitute in a 27. So let's do that and find out how big all of our angles are. I'm going to grab myself a calculator. And I'm going to do for this first angle down here, it's 4 times 27. 4 times 27. This is 108 degrees. It certainly doesn't look like this is 108 degrees, but it is. It looks closer to an acute angle to me, but it is what it is. 2 times 27 for this one is going to be 54 degrees for this angle here. This one's going to be 3 times 27 minus 2. So 3 times 25 is 75 degrees. And then this angle is going to be 27 plus 96. So this angle is going to be an obtuse 123 degrees. So my angles are 123, 75, 54, and 108. We can check because all 4 angles should add up to 360. If I had a pentagon, I'd have 5 angles. They would still add up to 360. Let's see, 108 plus 123 plus 75 plus 54 adds up to 360. I can feel confident that those are the correct 5 angles. Okay? All right, you do have your independent practice where you'll be practicing doing each of the things that we just did in the notes. They will be due the very next school day. In Schoology, you should have them complete. All right, thank you so much for watching.